Hello students. So today we are going to discuss about the linear regression, which is one of the most important topic of probability and statistics. I am Dr. Arunava Majumder, and today I will teach you the linear regression, some basic formula of linear regression, and some hands-on practice, some practical examples of linear regression. So let's start with the scatter plot first. So what scatter plot is, let us suppose a data set is given to you. So here we can see this is our first data set. Here X is considered as the independent variable and Y is considered as the dependent variable. If we um, plot these points, look at the first point. What is the first point here? 1 comma 5. What is the second point? It is 2 comma 4 and so on. So if I plot the points in a graphical plane, we can see these plots are formed. So this is the plotting. These points, it is 1 comma 5. The second point is 2 comma 4. Third point, it's 3 comma 10 and so on. So if I plot these points, we can find some discrete points are plotted here and it forms a graph which is called the scatter plot. Now what this straight line is? This straight line, this is the best fit line. This is the best fit line and which is also called the regression line. So how this best fit line is plotted, it is based on the least square approximation method. However, today this is not our scope to discuss about how this line is plotted. That is what is the overview of least square approximation. But the best fit line equation we will discuss now. So the equation, since it is a straight line, that is why we say it is a linear regression. So we have to plot or we have to form a straight line and which is the best fit according to these points. So what best fit means? Roughly you can say the same number of points is situated the upside of the straight line and almost the same number of points is situated on the downside of the straight line. Some points may also be on the straight line like this, and we need to find out the equation of the straight line. And what is the equation? We know that every straight line equation is almost roughly is equal to, sorry, it's equal to y equal to mx plus c. M is the slope and c is the constant term which is also called the intercept. Now this is the, you can see the slope 2.8 is the slope and intercept is plus 0.8. This is the intercept of this equation. So this equation y equal to mx plus c, this equation is called the regression equation of y on x. We will discuss the same thing later in the slide. Now the same plotting, you can see I have plotted another graph, but data points are same, but we just interchanged the values. That is x to y and y to x. We have interchanged them. So the now y becomes here independent and x becomes dependent. Now the points, it is 5 comma 1. Previously it was 1 comma 5. Now it is 5 comma 1, 4 comma 2. Just the exactly the reverse. As we have interchanged them, interchanged the variables. So now these points are quite different, and we also are getting another line of the equation y equal to 0.322x plus this. Okay, so These two, if we interchange the plottings, okay, interchange the lines, you can see also the equation is changed, and the slope is also changed here. This is the slope. So now we see that these two lines, if we interchange these points, we got two different lines. So one line is called y on x, another line is called x on y. So now we will discuss about how this x on y and y on x lines are formed. So these are the formula of the regression line of y on x, which is y minus y bar is equal to byx into x minus x bar. Now what is y bar? Y bar is the mean of y, and x bar is the mean of x. What is byx? Y and x, those are the variables. Y is dependent and x is the independent. What is byx? Byx is called the regression coefficient. The regression coefficient of y on x, since this is the regression line of y on x. So basically what we need to find, if we are going to calculate the regression line of y on x, generally we have to find out an equation which which looks like this: y equal to mx plus c type, y equal to mx plus c. Similarly, the regression line of x on y, exactly the opposite, that is x minus x bar is equal to b xy into y minus y bar. Now here x bar and y bar is mean of x and mean of y. I'm not going to repeat it again. B xy is the regression coefficient of x on y. So only this is the difference. Now here, what type of equation generally we need to find out? We need to find out the equation of x equal to my plus c. They here, of course, there is if I call it, it is m1 and this is m2. Of course, m1 and m2 may not be same. Okay, so c also, this is c1 and this is c2. Okay, so generally we need to find out an equation x equal to my plus c type, which is also another form of the straight line, but x is on the left hand side, whereas in the regression line of y on x, y should be on the left hand side. Now what is the formula of byx? Byx, the general formula of byx, it relates the correlation coefficient also. It relates the correlation coefficient, and if it is byx, we will write byx equal to r into sigma y by sigma x. Now what is r? R is the Carl Pearson correlation coefficient. Okay, I do not have the scope to discuss how to calculate the correlation coefficient, because already in another video we will discuss how to find out the correlation coefficient and what is it, everything about it. Sigma y and sigma x, there sigma y is the standard deviation of the y data, and sigma x is the standard deviation of the x data. However, there are different formula is there when we solve any example of a large data set. We of course should not use this formula of byx or bxy. We will use some another formula which I will discuss in the next slide. So similarly, bxy is equal to r into sigma x by sigma y. Okay, so here r sigma x sigma y is are same as we discussed here already. So let's go to an example now. So before starting the example, I told you already that there is another formula of bxy and byx for if a data set is given to you, basically a large data set or some bivariate data x and y values are given to you, you should apply these two formula for that. The bxy is this one and byx is this one. Now let's go to the example. So these are the data set which is given to you, x and y values. So you can see x values, it varies from 1, 2, 3, 4, 5, 6, and 7. And y values are 9, 8, 10, 12, 11, 13, 14. So here we need to calculate or we need to find out the regression equations, both for y on x and x on y. Okay, so I told you before that use the formula b xy and byx, which is written on the above slide, this one. So accordingly, so here you just need to make a table, and this table we will discuss about the x square, y square, and x into y. Okay, so this is the values of x square. You can see one, the 2 square. This is 2 square equal to 4. This is 3 square equal to 9. Sorry, 9 is already written. And now this is 4 square is equal to 16, and so on. Similarly, y square values you need to calculate. So first y value is 9. So 9 square 81, 8 square 64, and so on. And the third value, this is the value of x into y. So x into y, if you multiply 1 into 9 is equal to 9, 2 into 8 16, 3 into 10 30, and so on. After that, what we should do, we just add each and every column. That is, add all the numbers here, what we got. So summation of x we got as 28. If you add all these numbers, you get 28. Similarly, sum of y 77, sum of x square, it is 140. It is 140. This is 77. That's 28. Sum of y square 875, 875, and it is 334. Okay, and so on. So these are the calculations which you need to find out. After that, for the if you see the regression equation formula, what we need x bar and y bar. So x bar, we know that the x bar is the mean of x. So sum of all x divided by the number of terms. So number of terms here it is 7. So it is equal to 4. Similarly, y bar it's 11. Now here we have calculated one equation which is the regression equation of x on y. So according to our formula, it is x minus x bar into bxy into y minus y bar. Now bxy formula, you can see if you see this formula, every term has already been calculated. Sum of xy is 334, we calculated here. Sum of x is 28, we calculated here. Sum of y is 77, we calculated here. Now n is 7. Similarly, sum of y square and sum of y whole square. Everything can be calculated from the table only. After that, after the calculation, we can get the value of bxy as this. And in floating point value, it is calculated at 0.929. So we will just put it into the equation of x on y. So each and every value, after putting each and every value, we can get this is the equation of x on y after the simplification. Okay, so you can see the bxy value is basically it represents the slope. Similarly, by applying the other formula, that is byx formula, this one, we can find the value of y on x. That is the equation of y on x. Okay, here also we can get the same, the regression coefficient is formed 0.929. So I think now this will be clear to you that how the regression equations of x on y and y on x is calculated for a given data set. Okay, now for simplification, let me discuss another thing, the change of scale and change of origin. Sometimes the value of x and value of y, they may be larger. Let us suppose the value of it is 100, 200, 300, and the y values, let us suppose it is 1000, 1500, 3000, 5000, 7000. So to reduce the values of x, that is these values, it is difficult to calculate with these large values. So what we can do, we can uh, reduce this value by using the change of scale and change of origin. So or both simultaneously. That is, we can use a formula like this: x dash is equal to x minus a divided by b. A and b values you can choose according to yourself. Okay, so that these values can be reduced. Let us suppose here we can choose a equal to 300. You can choose any other value also. It doesn't mean that you have to choose from the table. Other than the table, you can also choose any other value. Similarly, b equal to some constant value you can choose, and the value of x can be reduced like this. Similarly, the value of y can also be simplified like y minus a dash by b dash. You can apply a dash and b dash value according to yourself. Okay, go to the next example. This example, two regression lines are given. However, which one is y on x and which one is x on y is not given here. So that is why let us suppose that the first equation, this is y on x equation, the second equation is x on y equation. So what kind of different questions can be formed from this type of question, this type of question formation? First, somebody can ask you to find out what is the mean of x, that is x bar, that is x bar, and what is the mean of y, that is y bar. Okay, so basically there is a rule that the regression equations y on x and x on y, they, if suppose these two equations, this is y on x and this equation is x on y, these two straight lines will intersect the point x bar, y bar. Okay, so basically simply if you solve these two equations, and whatever the value of x and value of y you will get, that value will represent the x bar and y bar itself. Okay, so after if I solve these two equations, so what we can get, so you can see these two equations are simply the linear equations with only two variables. So we can multiply the first equation by 2 and subtracting these two equations, we can get the x equal to 130 and y is equal to 90 after solving. Okay, I'm not going to solve these two equations here because this is not the scope of this lecture. So after solving these two equations, we get x equal to 130 and y equal to 90. And these two equations, basically, this is x bar and this is y bar. So the values of x bar and y bar, it is 130 and 90. So this is question number 1. Another question may be formed like this: find the values of byx and bxy. Generally, byx, it is represented by the slope of the equation y on x, and bxy, the slope of x on y. So from the first equation, we convert the equation, since the first equation is considered as y on x. So 2y minus x minus 50 is equal to 0. We convert this equation as y equal to mx plus c form, because this is the equation of y on x. So 2y implies y equal to 1 by 2x plus, and 50 by 2, it is 25. So what is the value of the slope? The slope is 1 by 2, and also this represents the value of byx. In the similar manner, from the second equation, since the second equation represents x on y, so we will form an equation like x equal to m into y plus c. That is, x will be on the left hand side. So let us find, so minus 2x. Okay, let me write down the equation first. So 3y minus 2x minus 10 equal to 0. So if I convert this equation, so we are getting minus 2x is equal to minus 3y and plus 10. After multiplying minus sign and dividing by 2, we are getting x is equal to 3 by 2 y minus 5. So 3 by 2, it is the slope as well as it is the value of bxy. Another question can also be formed from this: find the value of the correlation coefficient r. Find the correlation coefficient r. Correlation coefficient. So there is a formula between the correlation coefficient and the regression coefficients. The formula is given as r is equal to plus minus under root byx into bxy. Okay, these two formula basically we can find from here only, byx and bxy. If you multiply byx into bxy, we can find r square. Only r square, because sigma y and sigma x, they will be nullified each other, because it is sigma y in the numerator and here sigma y is on the denominator, and here it is sigma x. Similarly, one numerator, another one is denominator, they will nullify each other. So here we can get r square equal to this. So from where we can get r is equal to plus minus under root byx into bxy. So this formula we will apply here to find the correlation coefficient. So it will get, we will get, so this is equal to plus minus under root 3 by 2 into 1 by 2. So it is basically plus minus root 3 by 2. Now question is, which sign should be taken, plus or minus? One thing you should notice here, so baxy and byx, okay, they both should be positive or either both should be negative, because otherwise one is positive and another is negative, it will create a negative sign under the square root, okay, which is not acceptable. So either the both are positive or both are negative. If one of them is positive, you will consider the positive sign. If one of them is negative or both are negative, you can consider the negative sign. So here, since both are positive, both byx and bxy, so we will consider, sorry, the positive sign. So this is equal to plus root 3 by 2. Next question. This is important, and one of the means, you can say it's an industrial example. So the data of sales and the advertisement cost are given here. The original data set is not given, that is what is the sales and exact sales, mm, and exact values of the advertisement cost or advertisement expenditure are not given in this data set. However, the mean values are given, that is the average sales and the average advertisement expenditure is given. Also, the standard deviation of the sales and the standard deviation of the advertisement cost is given. Another thing is also given, the correlation coefficient 0.9. So we know that, and this is a, we need to find out basically a projected value, that is a prediction. Okay, that is we need to estimate the number of cells. Basically, we need to estimate the number of cells if the advertisement cost is 10 crore rupees. Okay, so basically, in industry, they are investing in advertisement just to increase the sales. As more advertisement is there, if um the product which the industry is making or manufacturing, if people are not aware of that particular product, so how the selling will increase? So of course the advertisement is necessary for that. So as much as you invest in advertisement, okay, there is a very means positive relationship that yes, the sale may also be increased in that proportion. So this is a data for that the sale is 40 crore mean sale. Mean means is the average selling. So 40 crore is the average selling if the advertisement cost is 6 crore. Okay, the advertisement average and both are at average. This is also average. These are also average. And the standard deviation is also given. The standard deviation, it is 10 crore and the advertisement cost is 1.5 crore. Both are given. Now to estimate, for the estimation case, we need a model. What model? The linear regression model here. Okay. Any other non-linear model is also applicable, but here we will apply the linear model only. Okay, so linear model means either x equal to, sorry, y equal to mx plus c or x equal to my plus c. So if I consider x as sales and advertisement cost y, okay, so we need to estimate which one? We need to estimate the sale. Okay, since we are going to estimate the sale, that is we are going to predict the sales value, and sales is on x, so we have to find out an equation like x equal to my plus c type. Okay, and x equal to my plus c is nothing but the regression equation of x on y. Yes, you can also interchange the values. That is, you can also find out the sales as y and the advertisement cost as x. That depends on you. But here, since I am going to means consider sales as x independent and sorry dependent, and the advertisement cost as y independent. So, what is the equation of x on y? We know that the equation is x minus x bar is equal to b xy into y minus y bar. And since here the standard deviation of x, this is standard deviation of x, that is sigma x, and this is standard deviation of y, that is sigma y. These two are given. Of course we will apply the formula of byx and bxy, this one, which relates the correlation coefficient sigma x and sigma y. Okay, and every value's correlation coefficient value is given, sigma x value is given, sigma y value is also given. So let's go to the example again. So here we can write this x minus x bar r into b sigma x by sigma y into y minus y bar. Okay, so what is x bar? X bar is given the mean of x. This is x bar. The x bar is 40. R value is 0.9. Sigma x, that is standard deviation of x, is 10. Sigma y, standard deviation of y, is 1.5 into y minus y bar. What is y bar? The mean of y. This is y bar, mean of y, which is 6. Now we simplify this equation. Remember, this is multiplication. So now we simplify this equation. So after simplifying everything, I think this is 0.9 and 1.5 and 10. So it becomes 6. So after simplifying, we can get it is x minus 40, 6y minus 36. And again after simplification, we can get x equal to 6y plus 4. So this is the model or predicted model according to this given data set. Okay, and now we need to predict the value of x. Value of x means the value of cells. What should be the number of cells if we expend rupees 10 crore to the advertisement cost? So advertisement cost, of course, it is represented as y. So we will put the value of y as 10 here. So if I put y equal to 10, okay, it will give us x equal to 6 into 10 plus 4. So it is 64. So what is the sales, average sales? It should be 64 crore if we invest 10 crore to the advertisement cost. So hopefully I can explain. I explained all type of almost all type of examples for linear regressions. Okay, however, there are other type of examples, or many other examples are also there. So these are the some main examples which I need to discuss. So I have discussed all of this. The examples on correlation coefficient, rank correlation coefficients, and the repeated ranking correlation coefficients, everything we will discuss in another video. And so thank you for today, and thanks for watching my video.